A warm greetings for the day. This is Chethan Kumar from WorkNaved and I welcome all of you to this video on number properties. And I hope that your preparation for the upcoming placement or the competitive examination is on track. And today's video will cover 5 typical types of problems from the concept of number properties. So after attending today's session, you will have all the confidence to attempt these 5 types of problem from number properties without any hesitation. And putting a little bit of extra effort, you will also be able to solve this problem in less than 15 seconds of time. So without wasting much time, we will quickly deep dive into the 5 problems. And the question number 1 for all of you is available on the screen right now. Read the question properly and look at the option and take complete 1 minute of time to solve this problem. For that purpose, I want all of you to pause this video for some time and start solving. Alright, so I hope many of you have got your answer. Some people might have got 7 as the answer, some people might also have got 0, 1 or none. But let us check how to solve this problem. But before that, the answer to this question is 0. So congratulations people who have got 0 as the answer. Now how to solve this problem? See, to solve this problem, you should definitely know the divisibility property of number 72. I know your teachers might have taught you till divisibility property of 10 or maximum number 12. Now how to do this problem? Simple, 72 is a composite number and if any number is said to be divisible by 72, it has to be divisible by both 8 and 9. If you confirm that the number is divisible by both 8 and 9, then automatically that number becomes divisible by 72 as well. Now, divisibility property of 8 says that last 3 digits of any given number must be divisible by 8. In that case, you don't have to check for the entire number, the number automatically becomes divisible by 8. And divisibility property of 9 says that sum of all the digits in the given number should be divided by 9. In that case, the number becomes divisible by 9 and this is something you already know. Now we'll check the divisibility by 8 first because this is comparatively easier than the divisibility by 9. Now, if 24y is divided by 8, then y value can never be 1, 3, 5, 7 and 9 since these are odd numbers. Odd numbers cannot be divisible by 8, right? So these are gone already and the possible values will be 0, 2, 4, 6, 8 and out of this again you can check what are the values are eligible and what are the values that are not eligible. See, if it is 240, that is if the number is 240, it is divisible by 8, so 0 is possible. But 242 is not possible, 244 is not possible, 246 is also not possible, but 248 is possible. So now you have got to know that only 2 values are possible for y. And now for those 2 values, substituting those 2 values, you have to check the divisibility by 9. Then you will get the x value as well. Now, people got 0 as the value of y in the first case and y can also take the value as 8. Now what will happen in each case? We will check that. Look at here, if y value is 0, then I'll check the divisibility by 9. How? Sum of the digits should be divided by 9, right? 7 plus 4 is 11, 15, 23, 25 and 29. You got the sum as 29 because y is 0. 29 plus 0, of course it is 29 itself. So you got the sum of all digits as 29 plus this x I have not considered and that value I got as x. Okay. Now see, this number should be divisible by 9, right? Now 29 is not divided by 9. Next number after 29 which is divisible by 9 is 36 and to make that value as 36, I need the x value to be 7. So you got to know that your x value has to be 7 in this case. Now check what is the value of x minus y. X minus y giving you the answer as 7. Now out of excitement, many people end up ticking 7 as the answer. If 8 is the value, then the value could be lesser than 7, right? You don't know. And that's the reason you have to check for 8 as well. Substituting the value of y as 8 and I will check that now. 29 is the value already, I know that, but after putting the value of y as 8, the sum becomes 37. Okay, and plus x will be the sum, right? The next number after 37, which is divisible by 9, is 45. And how much extra is needed to make this number into 45? X value will be that value, so that is 8. So x value is 8. Now tell me, what is the x minus y value? X minus y value is 0. Now tell me, between 7 and 0, which is the minimum value? Minimum is 0, right? And that's the reason 7 is not the right answer, 0 is the right answer. So I hope that the concept is clear for everyone, and we'll directly move on to the next problem. Next problem is slightly difficult than you think, and many people, when they appear for GMAT or any competitive or entrance examination, they will get this kind of a problem, and it is slightly difficult than all the other types of problems. The question is over here, the same strategy, pause the video for some time and then try to solve the problem and try to get the answer, and answer choices are also available. Okay, now let us see what could be the answer to this question. Now, this is a problem on units digit. So that means if you simplify this expression in that particular product, what will be the units digit, right? Now, the number is huge. The power is huge over here, and you can understand this problem cannot be solved manually. There should be some shortcut, right? And the shortcut is here. Simple shortcut. Please make a note of this. Answer is 1, so people have got the answer as 1, you're absolutely right, and we'll check how the answer works out. For time being, we'll ignore this factorial value. Okay, for time being, we will ignore this factorial value. So we'll solve this problem. 7 to the power 77 into 3 to the power 39. If this was the question, what could have been the answer? Something like this. I'll tell you, 7 power 1. The unit digit is 7, right? And what is 7 squares unit digit? That is 9. What is 7 cubes unit digit? That is 343 is the value, and then you get 3 in the units place, and 7 to the power 4, I don't know, but I know the units digit is 3 into 7, right? Which is 21, last digit is 1. So that means irrespective of any power, 7 raised to something will always give you the units place in the fixed format, and that format is this 7931, 7931. This is a cycle, and it continues like this. After every 4 iterations, the same format is going to repeat, and that is for sure. And 7 to the power 77 will also have any one of these 4 possible unit digits. It could be 7, it could be 9 or 3 or 1. Okay. Exactly in the similar way, 3 also has the similar kind of a pattern. That is 3 power 1 is 3, 3 square is 9, 3 to the power 3 is 27 and the units digit is 7, 3 to the power 4 is 81 and the units digit is 1. You can see, and irrespective of any power, 3 raised to something will have any one of these 4 digits in the units place. Now we'll check it out. There is a strategy. How to find out the units place? Simple strategy is, if 7 raised to something is there and if you have to find out the units digit, divide the power by 4 and check whether that power is divided by 4. And if that power is divided by 4, undoubtedly close your eyes and write answer as 1. Your units digit is 1, because every multiple of 4 will have the units digit as 1. That is for sure. Now, in this case, the 77 is not divided by 4, right? 76 is divided by 4. That you know that 76 is the previous value, and that is completely divided by 4, and that value 7 power 76 will provide 1 as the units digit. Now 7 power 77 is the immediate next value, right? That will definitely have the value as 7. Or other way of looking at it is, take the remainder when 77 is divided by 4. What's the remainder? Remainder is 1, right? So your answer is 7 power 1, that is 7. If you get the remainder as 2, your answer is 7 power 2, unit digit is 9. And if you get the remainder as 3, then your answer is identical to the unit digit of 7 power 3, which is 3. And if it is divisible by 4, then you know the answer directly as 1. And the same logic is applicable for 3 also. Now in this case the remainder is 1, then the unit digit is identical to 7 power 1, and here in this case the remainder is 3. Remainder is 3 because 4 9s are 36, remainder is 3. And in case of 3, if the remainder turns out to be 3, the units digit will be identical to 7. So 7 into 7 will give me 49, and the unit digit of this answer is 9. And many people end up ticking 9 as the answer just by making this calculation, ignoring this factorial. See, factorial is given for some purpose, right? You should not ignore that. So 9 is not the right answer. Answer is 1. But how? Simple. To understand that, you need to know the factorial concept a little bit, not much, a little bit. Now tell me, 77 factorial is the power, right? And I told you that you need to divide the power by 4 and check whether it is divisible by 4. So 77 factorial can be written like this: 77 into 76 into 75 and so on. Then 4 into 3 into 2 into 1. This can be written, right? And now 39 factorial can be written like 39 into 38 into 37, so on till 4 into 3 into 2 into 1. Now look at here, this number 77 factorial, tell me, is it divisible by 4? Simple, right? 4 cancels this 4, and that when denominator becomes 1, that is the indication that the divisor has completely divided the dividend. So 77 factorial is divided by 4. In the same way, 39 factorial is also divided by 4, since 4 cancels with 4 in the numerator. So that means both these powers are divided by 4. And I told you, when 7 raised to something and that power is divided by 4, the unit digit is identical to unit digit of 7 to the power 4, which is 1. And in case of 3 also, if the power is divided by 4, then it is identical to unit digit of 3 to the power 4, which is also 1. And unit digit of the first expression is 1, unit digit of the second expression is also 1, and 1 into 1 will give me 1, and that's the reason option C is the right answer. So I hope this concept is also clear to all of you. We'll move on to the next question, that is question number 3. And look at here, it's a different type of problem. Already we covered 2 types of problem, and now this is the third type, where they're asking you to find out the last 2 digits of the expression. Now you see 120 into 2587 into 247 into 952 into 854. Now before we get into the last 2 digits, you tell me, what is the last digit of this expression? Only the last digit. Simple, right? See, you need to take only the last digit for your calculation: 0, 7, 7, 2 and 4. Rest of the numbers you don't need. Now multiply all of them and then take the last digit. So 0 into something will definitely give you 0, right? And 0 definitely is the last digit of the expression, but they're asking you to find out the last 2 digits. So you cannot find out the answer directly like that, because 3 answer choices are having 0 in it. You cannot find out. So you need to know a shortcut to find out. And before I tell you the shortcut to find out the last 2 digits whenever a product is given, simple, I'll take the simple example, something like 45 into 22. Tell me, what will be the last 2 digits of this expression, 45 into 22? 45 into 20 will give me a 900 as the answer, and 45 into 2 will give me a 90 as the answer. So final answer is 990, if I'm not wrong. 990. Now for 45 into 22, it's an easy calculation and you can do this, but how to get the answer quickly, that is important. And that shortcut is, see, if they're asking you to find out the last 2 digits of any product, multiply that product divided by 100, take the remainder, and that remainder itself is the last 2 digit, right? Now divided by 100, right? I told you simplification is something like this: 5 9s are 45, 5 20s are 100. So that means you divided the numerator and denominator by 5. Then this number can be cancelled with the help of 2 stable, right? So then I divide this by 2, then I'll get 10 and this will become 11. Okay, this is 10 and this is 11. And now you know that 9 into 11 will become 99. Okay, 9 into 11 will become 99. Divided by 10, what is the remainder? Remainder is 9. Remainder is 9. You need the last 2 digits, right? But you got only single digit, 9. That's not right. Why you're getting single digit? Because you were asked to divide the number by 100 and then take the remainder. But now you are dividing the number by only 10. And why did you get this 10? Because initially you divided both numerator and denominator by 5 and then you divided both numerator and denominator by 2, right? So that means you have already taken out 5 into 2 from the given number. Now you have to give it back. What is 5 into 2? Which is 10, right? So you divided and now you have to multiply that number. So I'm sorry, it's not 100, it is 10. Okay, it is 10. What is 9 into 10? Which is 90. So the answer to this question is 90 for sure. So the last 2 digits of this expression is 90. Now what I have done, I have just multiplied and then divided by 100 and took the remainder, and that remainder itself is the value. Now I'll go to the problem directly. Here you see 120 into 2587 into 247 into 952 into 854, and I'll divide this number by how much? 100. I'll divide this number by 100 and I will take the remainder. Now you can see this number can be divided directly by 20, right? So 26 times and 25 times, that's it. No other number is possible. So that means I have cancelled numerator and denominator by 20. That means you divided the number by 20. Now this 20 should be multiplied after you take the remainder. That's it. That's the only procedure. Now tell me, what is the remainder when 6 is divided by 5? Remainder when 6 is divided by 5 is 1. Okay, into what is the remainder when 2587 is divided by 5? See, you know 87, last 2 digits, right? 87. 85 is divided by 5, you know that, and extra how much is there? 2 is there, so that's the remainder. Here in this case 45, if it was 245 it was divisible, but extra how much is there? 2, and that's the remainder. In this case again 50, if it was there then it is divisible, extra 2 is there, that's the remainder. And in this case 54, that means 4 is the remainder. So total remainder will become 4 into 2 into 2 into 2, and now I think it is definitely more than 5. So if it is more than 5, you have to again divide it by 5. 4 into 2 is 8, into 2 is 16, into 2 is 32. So now tell me, what is the remainder when 32 is divided by 5? Quickly. 32 is divided by 5, remainder is 2, right? Yeah, and last 2 digits of this expression will be 2, and that is ridiculous to say because there are no 2 digits here. Why there are no 2 digits? Because now you have divided the given number upon simplification, right? And initially you were supposed to divide it by 100, and this reduction happened only because you have divided the number by 20, right? So that's why you have to give it back. How will you give it back? Into 20. So 20 into 2 will give me a 40, and the last 2 digits of this expression will be 40. Take other examples as well in the similar manner, and you will get the proficiency in problem solving. Right. Now we'll move on to the next problem, and the question number 4 is over here. The question is, how many odd factors does number 3600 have? And your answer choices are here, and many people skip this question without even bothering to solve the problem. They skip because they don't know how to solve the factors based problem. And after this video you will never skip this kind of a problem because this problem has a shortcut technique, and that shortcut is here. Now before I move on to odd factors, I'll tell you how many factors, the total number of factors this 3600 has. To find out that, you have to first convert this 3600 into prime products. Okay, product of prime numbers you need to get. And I know many people are finding it difficult to find out the prime products of the given number. For those people, you can do it like this. Can I write 3600 as 36 into 100? This is something easy. Everyone can do this. 36 into 100. Now, I did not know 3600. It was a huge value. Now, I am in the reachable limits, 36 and 100. Now, for this, I can do it easily. Tell me, decompose this value 36 into shorter numbers. How will you do that? I'll do like 9 into 4. 9 into 4. You can go for 6 into 6 also. You will get the same answer. There is no problem as such. But 9 into 4 is easier for me. I'll go with this. Then 100 can be taken in multiple ways. Any way you can take. You can take it as 25 into 4, or you can take it as 10 into 10. But ultimately the values will be identical. There is no problem as such. And I will take it this as 10 into 10. For your understanding, I will take it 10 into 10. Now, you know all these values are not prime numbers, so I'll have to convert this until I get the prime number, right? So then 9 can be written as 3 into 3, right? So that gives me a 3 square. Now it is a prime number. 4 can be written as 2 square. Now it is also a prime number, but 10 and 10 are not prime numbers, so I'll convert them into 5 into 2. Okay, 5 into 2. Done. And now count all the number of prime numbers. You see 2 is present 2 times, and then additionally 2 times 2's are there. So total number of 2's will be 4. 2 to the power 4 into 3 to the power 2 into, and 5 is present how many times? 2 times. So now this is the prime factorization of 3600. And if you can solve the problem till this point, then 50% of your task is done. 50% of your task is done. Now, how many factors? Now, this is the total number of factors. Okay, total number of factors of 3600. How to do that? See, after you get this prime products, look at the powers. Look at the powers. You see 4, 2 and 2, right? Increment all those powers by 1. So 4 plus 1, you have to do that. And then you have to do 2 plus 1, and then you have to do again another power 2 plus 1, and then multiply all of this, and that is the total number of factors. What is 4 plus 1? 5 into 2 plus 1 is 3 into 2 plus 1 is also 3. 5 into 3 is 15, 15 into 3 is 45. So that means total number of factors number 3600 is having 45. This is the total number, and now they're asking you only the odd factors, right? And whenever it is a problem of odd factors, you just need to do this. See, 2 is a even number, 3 is an odd number, and 5 is also an odd number. So whenever you multiply a odd number into an even number, then product is definitely even. So you should not have any even number in the product, only then you will get the odd values, right? So that's the reason whenever they're asking you the odd factors, cancel out this term. Cancel out the term where you find number 2. Cancel out this. And if you cancel this out, what is remaining? Remaining is 3 square and 5 square, right? And then do the calculation. This portion will be removed. This portion is removed. And only the answer is this one, because this will give you the odd factors. What is the value? 3 into 3, answer is 9. That's it. Total number of odd factors is 9. Now, out of curiosity, I'm asking you, tell me how many even factors does number 3600 have? Now, logic is very simple. Total factors will be 45, right? And out of that, odd factors will be 9. Then tell me how many will be even? Yeah, 45 minus 9 will be 36. But many people might have a confusion. Sir, if only even factors are asked, then we have to find out the total, then we have to find out the odd, and then we have to subtract. No, I'm not saying that. You will get the answer here itself. In this step itself, you will get the answer. What is the answer? Simple. Odd factors, you know that, right? Remove this 2 and then multiply the powers, incremented powers of the remaining prime numbers. So then you get 3 into 3, which is 9, and then simply multiply it with the power of 2. That will give you the even factors. Now 3 into 3, I got 9 as the answer, right? 9 into 4 is 36 answer. Now for your understanding, I am asking you to solve this problem and you tell me the answer in the comment. How many odd factors does number 72 have? I want all of you to post this immediately in the comment. Right, so we'll move on to the next problem, and the next problem for all of you is over here. And this is the last question of this video, and this question is: find out the number of zeros at the end of n if n value is equal to 1 power 1 into 2 power 2 into 3 power 3 into 4 power 4 into 5 power 5. So on till 100 power 100. So now how to find out the number of zeros at the end? That means it is also called trailing zeros. This concept is also called trailing zeros concept, and trailing zeros basically mean it is the number of zeros towards the end of a number. For example, if 100 is the value, now the significant digit you can see other than 0 is 1, right? And after this 1, how many zeros are followed towards the end? Said to be trailing zeros. And if I say number 45,000, how many trailing zeros are there? After a significant digit, how many zeros are there towards the end of that number? Then that numbers are called trailing zeros, right? So here we have 3. And now don't get confused with this 45,010. How many trailing zeros are there? Don't tell me 2, because trailing 0 is only 1. You cannot consider this because after this one more significant digit is there. Now I'm telling you trailing zeros are only those that will come towards the end of the number after a significant digit. If it was something like 45100, then I could have said that 2 trailing zeros are there, because this is the significant digit, and after this non-zero digit, how many zeros are coming are called trailing zeros. And how will you find it out is the question. Now to answer this question, you need to understand trailing zeros will be coming only if the prime product of that number is having 5 into 2 combination. For example, look at here. 100 is a number, and I'll consider this 100 as 10 into 10, and prime product, if I have to write the prime product, then I get 5 into 2 and 5 into 2. This is nothing but 5 square into 2 square, right? And now this prime product has how many 5 into 2 combinations? One is here and one more is here. This has 5 into 2 combinations, and that's the reason 100 has 2 trailing zeros. In this case, it's a very huge number: 1 power 1, 2 power 2, 3 power 3, 4 power 4, 5 power 5, all the way till 100 power 100. How many times 5 into 2 combinations are there? Counting it manually will be tedious task, right? And that's the reason I'm doing it like this. Tell me, in this sequence of natural numbers 1, 2, 3, 4, 5 all the way till 100, tell me number of 2's will be more or number of 5's will be more? Of course, you need to have 2 into 5 combination, but in this case, which value will be more? Definitely number of 2's will be more, because frequency of 2 is more compared to frequency of 5, because 2 comes after every 2 numbers, 2, 4, 6, 8, 10, but 5 comes only after 5 iterations, 5, 10, 15. So of course number of 2's will be more in this sequence. So whichever values frequency is less, you have to count only that number. Now in this case, number 5 is less, right? And that's why it is enough for me to count the number of 5's. Of course, those many minimum number of 2's will be definitely there in the value. So that is the number of 5 into 2 combination, and that's the understanding. Now, how to count the number of 5's in this case? Very simple, count it. How will you count it? See, first time 5 comes in 5 power 5, right? So how many times 5's are there? 5 times. And next time 5 will come in 10 power 10, and many people will not agree with me, sir, where is 5 in this? They might ask me like this. If 10 power 10 can be written like this, right? 5 into 2 whole power 10. So that gives me 5 power 10 into 2 power 10. That gives me total of how many 5s? 10 times 5s will be there. So in 10 power 10, how many times are there? 10 times. So this is for 5 power 5 and this is for 10 power 10. Now tell me, in 15 power 15, how many times 5 will come? Yeah, you're right. It is 15 times, and this will continue. In 20 power 20 it is 20 times, and then 25 power 25 it is 25 times, all the way, okay, all the way till 100 times 100. So these many 5s are there. So now how many 5s are there? Count, you have to add all of this, right? And that has a shortcut. 5 can be taken common outside, then you get 5 into 1 plus 2 plus 3 plus 4 plus all the way till 20. Now you know there is a formula to find out the sum of first n consecutive natural numbers. What is that formula? First n consecutive natural numbers, sum of those numbers can be calculated by the formula n into n plus 1 divided by 2. Now we have 20 numbers, right? So the sum becomes 20 into 20 plus 1 is 21 divided by 2, and this into 5 is there, and that's why I'm writing this 5 as well. So 2 1s are 2 10s are, you'll get 210 into 5, which is nothing but 1050. Many people might stop here and say the answer as option A, and that is why I'm telling you aptitude is so tricky. This is not the right answer, because unknowingly you have made a mistake, and that mistake is starting from here. This is for 20 power 20, right? You told me that there will be 20 times 5, and in 25 to the power 25 you counted 25 5s will be there, but this is wrong, because 25 to the power 25 is written as 5 power 5 whole power 5, right? Sorry, whole power 25, right? And this can be rewritten as 5 power 25 into 5 power 25, and that gives me a 5 power 50. So how many times 5s are there in 25 times 25? It is 50 times, but you have taken only 25 times, right? And that 25 should be added here. Okay, in 25 to the power 25 you counted only 25 5s, but additional 25 5s are missing, and you have to give that back. Now tell me, same way happens in 50 power 50, right? Because you have taken only 50 times 5, but this gives me 100 times 5. So how much extra you have left out? 50. And in 75 power 75 you have taken only 75, and extra 75 is there. And in 100 power 100 you have taken only 100 times 5, but extra 100 is also there. So if you add all of this, you will get 100 plus 70 plus 75 plus 25 is also 100, 200, 250. So extra 250 is there. That's the reason answer is not 1050, but it is 1300 or 1300. That's the final answer to this question. So I hope that today's video was useful to all of you, and you have got to know 5 different types of problems from the concept of number properties. And if you want such kind of videos frequently in the near future, please tell me that in the comment, and whichever concept you feel bit uncomfortable to solve, mention that topic in the comment below, and I will be happy to solve those kind of problems and give you the solution as much as I can. So thank you so much for watching my video, and if you have not subscribed to our YouTube channel, we will highly encourage you to do that. And don't forget to hit that bell icon, because every single time when we post a new video you will definitely get notified. That's all from this video, and I will meet you in the next video with a new concept. Until then, it's bye bye from Chethan Kumar. Have a great day ahead.